dirty and smelly. So they first add a powerful form of the chemical element carbon, called activated carbon. It absorbs contaminants such as solvents and pesticides. That rids the water of bad taste and odor. From there, the water then goes through a series of mixing tanks. The first tank holds a chemical called aluminum sulfate. It acts as a coagulant, a substance that thickens liquid into globs. In the raw water, the aluminum sulfate forms tiny sticky globs called flocks. Bacteria, mud, and other impurities stick to those flocks. Then the flock-filled water moves on to the second mixing tank. The second tank holds a chemical called polymer, which is essential to the next step of the process, called sedimentation. 5 pipes inject the water with superfine particles of sand called microsand. The polymer coats the sand, making it sticky. The grains of sand then stick to the flocks in the raw water, weighing them down even more. The water then flows into a settling tank where the flocks, because they're heavier, settle to the bottom. You can see the result in this demonstration. The water is finally clear, but it's far from drinkable because it's still full of bacteria, viruses, and other organic matter. So on to the next step, filtration. The water flows onto the top of the filter, then trickles downward, passing through a layer of anthracite, a type of coal, then through a layer of sand. This filters out any remaining particles, which then flow to the middle. But the water is still teeming with bacteria and viruses, so it has to be disinfected. They add 1.9 milligrams of chlorine per liter of water, enough to kill off those germs and bugs. They add a mineral called silicate to prevent calcium buildup from blocking our water pipes. The treatment plant sends water samples to government inspectors who continuously monitor the water supply to ensure it meets safety standards. The amount of chlorine remaining in our drinking water is 0.6 milligrams per liter. The chlorine gas the plant uses is highly toxic. Should any leak out, emergency teams would have to evacuate a 10-kilometer radius. So the plant stores the drums of chlorine in a high-security area. It's taken about 45 minutes to turn raw water into treated water. Now these electric motors will pump it through underground pipes right to your tap. Short-sightedness, far-sightedness, and astigmatism are all due to light not focusing precisely onto the retina. Surgeons can correct this by using a laser to reshape the curvature of the front surface of the eye, called the cornea. The surgeon operates on one eye at a time. He cleans the eye, the lid, and the lashes with antiseptic, and administers anesthetic drops to freeze the eye and lid. He opens the lid wide with a speculum, then rinses the eye with a saline solution. Everything's frozen so the patient doesn't feel a thing. Next, antibiotic drops to prevent infection. Before every operation, the surgeon tests the equipment. He fires the laser on a metal plate to test its energy level. The surgeon administers a few more anesthetic drops, then inspects the microkeratome, the device he'll use to lift a very thin layer from the outer surface of the eye. He also measures the patient's cornea using an ultrasonic instrument. The cornea must be a minimum thickness for it to be safely reshaped. The surgeon uses the speculum again to prop the lid open. Then he begins the operation. marks the eye with sterile ink, reference marks he'll use later. Next, he positions a metal ring around the cornea. The ring is attached to a suction pump so it clings to the eye. Like holding a tomato steady while you slice it, it holds the eye steady while the surgeon cuts the tissue. The surgeon lubricates the eye with sterile water, then mops up the excess water with a small absorbent sponge. Then he takes the microkeratome and slips it into grooves in the metal suction ring. In a matter of seconds, the device moves across the eye, cutting open a flap of tissue, the same way a carpenter's plane shaves a layer of wood. The surgeon uses a sterile sponge ring to keep tears from contaminating the cornea. He folds back the flap of tissue, exposing the cornea. He mops up the excess liquid, then starts up the laser. Meanwhile, a tiny sponge keeps the flap moist. The laser, an invisible light, fires in pulses, 50 pulses per second. Each pulse vaporizes a 1/4 micron of corneal tissue. The laser has been computer programmed beforehand, so it knows exactly how to reshape the cornea to give most patients 20/20 vision. In less than a minute, it's done. The surgeon removes the sponge and then, using those little ink marks he made earlier as reference points, folds the flap back to its original position. If the flap isn't precisely where it was before, the patient will have distorted vision. Using a syringe that flushes the area with sterile water, the surgeon carefully smooths the flap, the same way you'd smooth out a tablecloth. Then he removes the sponge ring. Within 45 seconds, the negative pressure inside the